Good morning, guys. Today our topic is spectrum, and then it will we will start the Fourier series. Okay. So, what is spectrum? Spectrum is the specific range of electromagnetic waves, such as light refracted when passes through a prism. If you can see, uh, if we apply some prism and a light is going on, then it will be diffracted into 7 colors. Okay, so this is called a spectrum because a specific bandwidth wavelength and wave are mixed in this range, from this range to this range. So this is called spectrum. Okay, so there is a so many definition. First of all, we'll go for this, then we'll one by one discuss. In plural form, it is called spectra. Okay, so spectrum, or in plural, it is called spectra or spectrums. You can say also spectrums. Is a condition that is not limited to a specific set of value, but can vary without steps across a quantum. Okay, just write down this definition. If spec in plural, it is called spectra, not limited continuum. Okay, the word was first used scientifically in optics. Okay, no of colors. Okay, so it is an arrangement according to the wavelength of visible UV and infrared light. Okay, and the spectrum is specific range of electromagnetic wavelength such as white light diffracted when passing through a prism. So if we see, look, if we start from 3 hertz, a wavelength that is 3 hertz up to this is radio wave, this is radio wave. Okay, this is microwave, this is 20 kilohertz, you know, this is 20 kilohertz, and this is after this range is 308 gigahertz, that is used in radar. Okay, it is coming over here. Then it is coming the TV remote infrared. This is your example. Okay, and this is your TV remote IR infrared. You all know that in your TV remote there we are using generally only IR rays. Okay, TV. Then this portion is under visible range. Okay, and this portion going under the UV ray, UV. It is coming from sun. Okay, for example, and this is this range, after this range, that is X-ray. Okay, then it is coming gamma ray, that is 300 E hertz. So this is a spectrum, but you can see this is a continuous signal, but there is also a discontinuous time signal also exists. That is where if you want and to know where this discontinuous or discrete uh, spectrum are used in your microwave, whenever microwave using channelize a wave in a metal guided area, then it became, we are using the discrete spectrum. Okay, so there is also exist a discrete signal, just discrete signal, just like this. This is your discrete signal. Okay, so this is your discrete signal. Where it is used? In your microwave. So you can see that is discrete spectrum. So if physical quantity T is said to have a discrete spectrum, only distinct values are exist with gaps. So in a discrete physical spectrum, there is a physical quantity. It is there, but there is a, within these two physical quantity, there is a distinct gap is there. Okay, then this is called the discrete spectrum. Okay, so there is existence of two spectrum, discrete spectrum and the continuous spectrum. What is continuous spectrum? You can see in previous, this is this continuous spectrum. So a continuous spectrum contains many different colors or wavelength with no gap. That is, you can see that is this type of spectrum is called the continuous spectrum. Okay, so this is a little about idea regarding this spectrum. Now we are going for the Fourier series, and this is the trigonometric Fourier series we have to discuss. Look, uh, it was the trigonometric Fourier series. What is Fourier series? Actually, Fourier series was first discovered when it was going to study the heat flow, and scientist Fourier discovered that a non-sinusoidal periodic function can be expressed as an infinite sum of sinusoidal function. Non-sinusoidal, okay, non-sinusoidal the periodic function, it must be periodic. Periodic means after a few time, after a repeated gap, the signal should be repeated. Say this is a, if this is your signal, then after sometimes again this is repeated, again this is repeated. If this is repeated, then this is called periodic. If this is not repeated, then this is called aperiodic signal. Okay, so while scientist Fourier study the heat flow, then he realized that a non-sinusoidal Fourier non-sinusoidal periodic function, non-sinusoidal periodic. This is not sinusoidal. It may be square, it may be triangular, whatever may be, but not sinusoidal, cosine, whatever may be. This function can be expressed as the infinite sum of sinusoidal function. Okay, so this is your Fourier series, and it may be said that a periodic function ft, a periodic function ft is expressed in such a way that t plus nt. You can see, we know ft, this is a ft, say this is a function, or if you take any function that is a, say this square wave, okay, step functions, you know this is a step function. But what is this? Just remember, in your previous classes, this is a time scaling factor. Okay, so whenever it is coming here n time, if n equal to 1 plus t, means, say this is, if t is 0 over here and t is, this capital T is 1. So whenever it is 1 is coming, say this is zero point 0.5, and say this is 2, t is 2. So this is, whenever 2 is coming, then 1, then again it start. Okay, again, if n into 2, if n is 2, then 2 into 2, that is 4. Whenever this is 2, whenever 4 is coming, again it is coming. They said n equal to 3, so n into 2, this is 6. So when 6 is coming, again it is exist. So in this way, Fourier series is expressed. This series is called the Fourier series. Okay, and just remember this ft, it is function of t and n of t. This is scaling multiplication. Okay, and it is period of function. This is period of function. Period of functions. So after every two, it will be repeated. This is the period, and this is n called integer. Okay, so according to the Fourier theorem, any practical periodic functions of a angular frequency omega 0 can be expressed as an infinite sum of sine or the cosine functions that are integral multiplication of omega 0. Thus, ft can be expressed in this way. You can express in this way, function of t, it can be expressed in this way, a0 plus a1 cos omega 0 t plus b1 sine omega 0 t. Okay, again, it, as this is periodic, an infinite sum, so you have to go for the infinite times a2. Again it is coming, I am writing another a1, then a2, then cos omega 0 t plus b2, sorry, this is 2, b2 sine 2 omega 0 t. Again, this is a infinite, so we have to write another term, that is a3 cos 3 omega 0 t. This 0 should be as a notification, a0t plus b3 sine 3 sine 3 omega 0 t. Okay, it is continuous to infinity. So according to the Fourier theorem, any practical periodic functions of the angular frequency omega 0, if the angular frequency is omega 0, can be expressed as the infinite sum of sine or the cosine functions. Okay, the integral multiplies of omega 0. Thus, this item can be written in this way. Okay, so if we go for the generalization, then we don't write up to the infinite time. We just make it as a summation. So you can see function of t, function of t is written as this a0, this initial point, then summation of this n equal to 1, because n equal to this is 1. Okay, n equal to 1 to infinity, and this is all, then an an cos n omega 0 t plus bn sin n omega 0 t. So you can see this is your dc term, means this is your dc term, and these terms are the ac terms. Okay, this is cos n omega 0 3. This is your AC term. If you can get some signal, then you can see there is a summation of plus DC signal and some, this is the AC signal. Okay, and this term is your AC term, means alternating term, and this equation is called trigonometric Fourier series. So once again, just remember, first scientist Fourier observed this thing whenever he working on the heat flow analysis, that is any signal, but it should be a periodic signal, can be represented as an infinite summation of a sine and cosine signal. Okay, or infinite summation of sinusoidal functions. Okay, and then he he represents this type of function. Any function can be repeated because this is a periodic signal. This is not saying any Fourier series, Fourier transform, nothing is there. This is a periodic signal, and if this signal is periodic, then it can be expressed in this time. And if any signal is periodic, and this should be a practical signal, and which angular velocity is omega 0, and can be expressed in the infinite sum of cosine functions and sine functions. Okay, so or you may say sine functions and cosine functions, and multiplication with this omega 0, and the integral multiplication and multiplies with the omega 0. Okay, say function of t can be expressed in this way. So this is your trigonometric expression of your Fourier series. And now if we go for details analysis, this omega 0 is 2 pi by t. Omega 0 means 2 pi by t. So this is called radian per second. This is called fundamental angular frequency in rad. This is called fundamental angular frequency. Frequency. And this sine n omega t or the cos n omega t is called the nth harmonics. This sine omega t or the cos omega t, this sine n omega 0 t and cos n omega 0 t is called the nth harmonics. Okay, and this a0 b0 is called Fourier coefficient. It is called Fourier coefficient. And now for n not equal to 1 are the amplitude the AC component. Okay. Thus, the Fourier series T into a DC component and an AC component comprising on harmonic sinusoidal series. So Fourier series of a periodic function ft is a representation that resolves function of t into a DC component and an AC component comprising on a infinite series of the harmonic sinusoidal series. You can see this is a DC component and this is the AC component. Okay, but the sum is infinite sum. So this is about your Fourier series. Now we have to know some formulas that is coming next. So a major task in your Fourier series is to determination of the Fourier coefficient a0, an and bn. This process is called the Fourier analysis. So from this series, you have to determine this a0, an, and bn, and this is, if you derive this things is called, because this is a normal thing. This is a sign in omega 0 t. Nothing is uh, calculated, but you have to calculate it. This a0 value of this a0, an, and bn. So this is called Fourier analysis. This things is called Fourier analysis. So major task in Fourier series determine the coefficient a0, an, and bn. You just remember an is concerned with cos factor and bn is concerned is with the sine factor, means sine omega n. So if someone you told that write down the Fourier series, then what, how will you write? Just write down this is ft. A0 is the initial condition, then plus summation of n equal to 1 to the infinity, then give a bracket, then first it is coming an with an is concerned with this is cos factor, cos n in omega 0 t, okay, plus then b0 sine, b is concerned with this sine in omega 0 t. So this is the representation, trigonometric representation of your or Fourier series. So in your Fourier analysis, there is a uh, two types of functions are there. First one is your Fourier analysis and Fourier transform. These two types of performance you have to perform. So when Fourier analysis is doing, in say some signals is given, then you have to find this a0, an, and this b, not 0, this is bn. So whenever you got this a0, an, and bn, then easily you can write down this Fourier series. This is your task. Okay. So one by one, I will show you how we can find out this a0, an, and bn. Then we can completely represent a Fourier series, and this analysis is called Fourier analysis. And another performance you have to perform in this Fourier series, you have to transform a signal into a Fourier signal. That is called the Fourier transformation. Okay. So guys, if you have any question, then you may ask me. In some example, you have to write down. That is this is formula. Sorry, 0 to t, 0 to t. That is sine in omega 0 t dt is 0. 0 to 2, this is integration is 0. Another thing, sine 0 to t cos n omega 0 t dt equal to 0. Okay. Then sine t, sorry, this is integration, sine n omega 0 t cos m omega 0 t dt equal to also 0. Okay. So 0 t, look, this is sine n omega 0 t sine m omega 0 t dt also 0, m not equal to n. Okay, m not equal to n. Just remember this formula. Here also n not equal to m. then sine 0 to t sine square in omega 0 t dt equal to pi by 2. Okay, pi by 2 sine square. Sorry, this is not pi, this is t. This is also t by 2. And another thing is there, 0 to t cos square in omega 0 t dt equal to t by 2. So by using this formula, we can find out any signal whether this is a Fourier series or not, or we can go for the transformation. So next day we will go for an example so that we can understand how we can analyze this a series, and then we have to find out A0, AN and BN by any given signal. Okay. So guys, if you have any question, then ask me. Otherwise, I am going to stop here. Okay, thank you. Thank you. Have a nice day.